Backtracking is an algorithmic technique used to solve problems by systematically exploring all possible solutions, building them step by step, and discarding those that do not meet the established conditions. In this sense, it is based on generating partial solutions that are recursively expanded, verifying at each stage whether they can lead to a valid solution. Likewise, when a possible solution does not meet the requirements, the algorithm backtracks to the previous step to test a different alternative, allowing for efficient traversal of the search space. Furthermore, this approach is especially useful in problems where it is necessary to evaluate multiple combinations, such as generating subsets, placing elements under constraints, or solving complex structures like boards or routes. Consequently, the application of backtracking allows us to tackle problems that cannot be easily solved with more direct methods, as it guarantees the complete exploration of possible solutions, albeit at a higher computational cost. For example, it is used in situations such as the 8 queens problem, solving Sudoku puzzles, or finding valid combinations in different contexts where multiple constraints must be met simultaneously. Similarly, this technique can be optimized through strategies such as branch pruning or search reorganization, thus reducing the number of paths to explore. Therefore, backtracking becomes a powerful tool for solving complex problems.